Let's take a look at example 8 coming from section 4.4. We want to solve the initial value problem y double prime plus y equals 4x plus 10 sine x. Again, as we kind of move through the rest of this chapter, some of the things might start to blend together, but the key thing you're picking up on, first of all, is that this left-hand side, it's a differential equation. It's linear. It's a linear differential equation with constant coefficients. And the right-hand side, that g of x is, linear combinations and products of polynomials, sines and cosines, and also exponentials. So we can solve it as the method we saw in the section. We're going to first, before we worry about even dealing with the initial value problem, the initial values, we want to find the general solution first. So we're going to begin by step 1. We want to find the complementary solution first. So let's find y sub c. To do that, we need to focus on the homogeneous linear differential equation y double prime plus y equals to 0. The auxiliary equation would be m squared plus 1 equals to 0. We can go ahead and solve for this. This would be m squared equals, you can take the 1 to the other side, subtract 1 from both sides, take the square root. M will be plus or minus the square root of negative 1, which is plus or minus I, or if you prefer, it has a real part of 0. So 0 plus or minus I. Therefore, y sub c, we have two complex conjugate solutions. It's going to be e times the real part of that complex number times x times c1 cosine. So alpha is 0 here, and beta would be 1. So it's going to be 1 times x plus c2 times the sine of 1 times x. Anything to the 0 power is 1. So we get that y sub c, our complementary solution, is c1 cosine x plus c2 sine x. Okay, so we already have that part done. Now let's go ahead and take a guess for our yp. If we look at yp, by looking at the function g of x and kind of using our table to guide us, this looks like a linear function. So we would propose, let's say, ax plus b, and then we have something that looks like a constant times sine x. And we know that if that's the case, then not only would we need the sine of x, but we would also need the cosine of x as well. Okay. Now, there's a problem with this. And the problem with this is that, wait a minute, if we look at this form here, okay, that would produce things that would be linearly dependent with our complementary solution. So this is kind of like the case 2 we were just covering a moment ago. So these two things wouldn't work. Okay. So how can we kind of remedy this? Well, as we saw in the past, we need to multiply each of those terms by a power of x so that there wouldn't be any overlap here. So we're going to call this cx cosine of x plus ex sine of x. And we're going to propose that as our form for our y particular. Let's now go ahead and plug this into the differential equation. So here's our yp. We need to come up with a second derivative. So we need to do the first derivative to begin. The derivative of ax plus b would just be a. To do the next couple pieces, these are going to be product rules. The derivative of cx times the cosine of x is going to be c cosine of x minus cx sine x, plus the derivative of this thing is going to be e sine x plus ex cosine x. if it helps, and maybe we'll do this, we can actually kind of group terms before taking the second derivative. Just kind of helps to keep things a little bit clean here. But if you look at our cosine of x terms, we have a c and then a plus e to the x cosine of x. Group them, factor out the cosine, it looks like this. And then similarly, if we look at our sine terms here, we would have like a negative cx plus e sine of x. Let's now go ahead and find y particular double prime. Derivative of a constant is 0, so that's gone. And we have to use the product rule here. The derivative of e to the x plus c, well, that's going to be just e times the cosine of x, and then plus, we have e to the x plus c. The derivative of cosine of x is negative sine x. Product rule here as well. The derivative of negative cx plus e, that's going to end up being just negative c times the sine of x plus negative cx plus e times the derivative of sine is cosine. And I'm going to just kind of come over here. Let me just write above so we don't lose it. We know that yc is c1 cos x plus c2 sine x. And we're now going to plug y sub p into this differential equation. So the second derivative, and I don't want to really kind of erase this form either. We know that this is the form y double prime, which is this. And let's clean that up first to see what we can do here. Let's help ourselves out here. So where are our cosine of x terms? Well, this term here and this term here are our cosine of x terms. We have an e plus negative cx plus e would give us a negative cx plus 2e cosine of x. And now these two things here would be like our sine terms. This negative sign, if you want to kind of remove it from the sign, it's probably more helpful to think of it as like negative ex minus c times the positive sine of x. So that when we look at the coefficient of sine of x, here's what we get. We have negative ex minus c minus another c will produce a minus e to the x minus 2c times the sine of x. And that's going to be our coefficient for that function. So let's plug it into the differential equation. So y double prime plus y, that's this thing here, negative cx plus 2e times the cosine of x plus negative e to the x minus 2c times the sine of x plus y p. Yp is this. So plus ax plus b plus cx cosine of x plus ex sine of x. This is supposed to be equal to 4x plus 10 sine x. 4x plus 10 sine x. And I don't want to erase this so that I can't recover it. Let me just write yp here so we remember the form. That way, once we solve for these undetermined coefficients, we recall where everything is going to go. Okay, now we got some room. So we again want to combine like terms to kind of help ourselves out. The polynomial comes first on the right hand side. This is the polynomial part we have here. We have ax plus b. The next thing, notice I don't have any cosine terms here, but I'll write the cosine term next. Traditionally, the cosine would come next. We have a negative cx plus 2e, and then we have another cx cosine of x. Those two pieces will cancel. At least part of it will. So what we're going to have as a result of that is just the 2e with the cosine x. If you don't like this, you could distribute it all out, or combine like terms, and then recombine them. But then something kind of similar happens here. If you try to combine the sine of x terms, we have a negative ex minus 2c sine x plus an ex sine x. The positive ex and the negative ex will cancel, and so we're going to be left with a negative 2c sine of x is equal to, I'm going to be very explicit here. We have 4x, there's no constant term, there's no cosine of x term, but then we have a 10 sine of x. And now what we're going to do from here is, again, we're going to equate coefficients. So the x terms have to be equal to each other in coefficient. The constant terms have to be equal in coefficient. The cosine of x terms have to be equal in coefficient. And the sine of x terms. It's kind of hard to read that one. Purple's not so great for this. There we are. And the sine of x coefficients have to match up. So this produces the following system of equations. A has to be equal to 4. B has to be equal to 0. 2e will be equal to 0. And negative 2c has to be equal to positive 10. Some of these already come out solved. We know a equals to 4, b equals to 0. If we divide both sides by 2, we would get that e equals to 0. And then here divide both sides by negative 2, we would get c equals negative 5. Therefore, our particular solution is going to be y equals, it's a times x, so that's going to be 4x. B is 0, so we don't have to write that. E is 0, don't need to write that. And we have ex sine x, or, excuse me, made a mistake here. C is the coefficient of the x cosine x term. That's negative 5x cosine x. And e is 0, so this term is not there. Thus, we have the general solution. So what is our general solution? Well, the general solution is y equals yc plus yp. That is c1 cosine of x plus c2 sine of x plus 4x minus 5x cosine x. So after all of that, we now have our general solution. Let's go ahead and solve the initial value problem by using the given information. One of the things we're told is that y of pi equals to 0. So if we plug pi into our general solution, we would get this. Y of pi is going to be equal to c1 times the cosine of pi plus c2 times the sine of pi plus 4 pi minus 5 pi cosine pi equals to 0. Cosine of pi is negative 1, so this is going to be negative c1. The sine of pi is 0 plus 4 pi. Again, cosine of pi is negative 1. Negative 5 pi times negative 1 will give us a positive 5 pi equals 0. So negative c1 plus 9 pi equals 0. Add c1 to both sides. We get that c1 equals to 9 pi. So c1's 9 pi. Now that I know that, we can just kind of go ahead and just plug that in. We still need to solve for c2. And in order to solve for c2, we need to use the information that the derivative evaluated at pi is equal to 2. So let's kind of go ahead and take the derivative of this function. So if I take the derivative of this, we're going to get the following. We're going to get y equals derivative of 9 pi cosine of x is going to give us a negative 9 pi sine x. Derivative of c2 sine x is going to be c2 cosine x. Derivative of 4x is 4. And now for this thing, we need to use the product rule. Derivative of negative 5x is negative 5. Leave the cosine alone. And then the derivative of negative, it will be negative 5x times the derivative of cosine, which will be negative sine. So this will turn into a positive 5x sine x. So that's y prime. We can now evaluate y prime at pi. It's going to be negative 9 pi times the sine of pi plus c2 times the cosine pi plus 4 minus 5 times the cosine of pi plus 5 pi sine pi. And this is supposed to be equal to 2. We know that the sine of pi is 0, so these terms are going to be 0. Cosine of pi we said was negative 1, so we have negative c2 plus 4. And negative 1 times a negative 5 will become a positive 5 equals to 2. Negative c2 plus 9 equals to 2. Negative c2 equals to negative 7. And therefore c2 equals to positive 7. So we substitute that in, and we have our solution to the initial value problem is going to be 9 pi times the cosine of x plus 7 sine of x plus 4x minus 5x cosine of x. And there you have it. That's the solution to the initial value problem. What makes this new, we've done initial value problems in the past. Now we're looking at it in the context of using our indeterminate coefficients method, but it still works out pretty much the same as what you're used to. You solve the differential equation, the full differential equation, as you did using methods in the section. You first find your complementary solution y sub c, you then find y particular, you add them together to get the general solution, and then only after you get the general solution do you substitute in the initial values to solve for the C1, C2, or any constants that you may have.